Hello and welcome. Today's lesson is titled Functions, Yes or No. Our objective today is to identify and justify whether a relation is a function. In mathematics, there's different ways to represent a relation between two numbers. I could use a coordinate plane or a graph like this. I could use a set of ordered pairs. Basically, each parenthesis is a pair of numbers, so -1 relates to 3, 0 relates to -4, and so forth. Could also have a table that describes that -1 relates to 3, 0 to -4, so there is the relations on that table. And the last form to represent a relation is by using diagrams, or some people like to call it mapping. So basically here I have the x values and here's the y values, and I notice the -7 is relating to -2. 13 is relating to -2 as well by the use of these arrows. And on the graphs, I forgot to mention, here we have -1 on the x-axis relates to, if I go up to this point right here, which represents the y value, which is 1. So, and if I use, like for example, number 2, I go up, it's probably going to hit somewhere here, which is 6. So 2 relates to 6 or something very close to 6. Okay. So now the objective today is, if I'm giving one of these representation, I need to decide if it is a function or not. And basically, if I have a graph and I want to decide if this relation is a function, I'm going to use what is called the vertical line test. And basically, what you can do is you use a pencil and you put it right there on the vertical next to your graph. And to be a function, the vertical line must touch only one point at a time as you move the line from left to right. So if you take your pencil and you move from left to right and you're only touching one point at a time, that means it is a function. Compared to this one, if I move from left to right, what's happening, I'm touching 2 points at the same time. So that means this is not a function. So if he only touches 1 point, yes, it's a function. If he touches 2 or more points, not a function. Now, if I have a set of ordered pairs, basically the rule to determine whether it's a function, yes or no, is whether the x values repeat. Because to be a function, the x values cannot repeat. So when I'm looking at a list of ordered pairs, I look at the x values, which is the first number of each parenthesis, and if those numbers don't repeat, then yes, it is a function. Compared to this one, the -2 repeats, so I know it's not a function. On the table, same thing. You look checking if the x values don't repeat, and it doesn't repeat here, so I know it is a function. Here we have a problem because -2 repeats, so this is not a function. So if you have a table or several set of ordered pairs, you do not want the x to repeat in order to be a function. All right, the last one is the mapping. And for this one, there's two conditions that must be met. To be a function, the x values cannot repeat, and there should only be one arrow coming from each number on the left. So right here, the first condition is met because the x does not repeat. The second condition is I only have one arrow coming from this number -7 and one arrow coming from 13. As long as you have just one arrow from each number, then it is a function. Compared to this guy, the x doesn't repeat, but the second condition fails because there's 3 arrows coming out of -3 and 2 arrows coming out of 10. So this is what we're going to do in this lesson. We're going to decide whether a relation is a function or not. If you have a graph, you do the vertical line test. You only can touch 1 point at a time. If a set of ordered numbers, you look at the x values. The x values cannot repeat in order to be a function. Same thing with the table. The x values cannot repeat. And on the diagram, there's two conditions. The x values cannot repeat, and you should only see one arrow coming from left to right. Okay, so now what we're going to do is we're going to try some problems. So here's the direction, and I made a typo here, so let me make a correction there. It's supposed to be circle. Circle whether each relation is a function or not, and select the reason or reasons why. So basically, I'm going to have a representation here, and I have 2 questions to answer. First question, is this a function? Well, if I take my pencil and I move from left to right, I'm touching 1 point, 1 point, 1 point. Uh-oh, right here I'm touching 2 points. There's a problem there. So that means it fails. It fails because it touches more than 1 point. So the answer is not a function. Now you need to tell me why you decide that it's not a function. If you notice, we touched 2 points. And right here is going to be a list of reasons that you can use to justify or to tell me why you chose this answer. So if we notice, we use the vertical line test. Anytime you have a graph, we're using vertical line test, and this is going to be the first 2 options. So because in the vertical line test, the line touches only 1 point, well, that didn't happen. We touched 2 points. Because in the vertical line test, the line touches more than 1 point at a time, so that's the justification that applies to this problem. Okay, and there are other justifications here that you can use to do that. Now, before we go on to the next problem, let me demonstrate what's going to happen on the Go formative, okay, because this is the paper version, which you're going to write it on your paper, so you can have this to study when you're studying for a test. But on the Go formative, let's take a look at the Go formative. So when you turn on the Go formative, this is what it's going to say, and basically the objective is to identify and justify whether relation is a function, and then the question is this a function? And we decided that no, it's not a function. Okay, and then we have these reasons here. Please notice that whenever you see the little square, means that you could select one or more than one. Okay, now basically for this particular problem, we selected the second one, and the other ones don't apply to the situation. So basically now we can press here, check your answer, and it's going to demonstrate if it's right or wrong. Okay, actually we can also put check your answer for the first one, and right there we see a feedback or information back to you saying, hey, good job, you did a good job. If it turns red, that means there's a mistake, you need to revisit and see what can be done. Also, if you have questions, you can ask your teacher, okay, or a friend to help you understand these concepts before we do a quiz or test or concept checker. Okay, so know that this is a valuable feedback to you, valuable information to help you build your learning in this class. Okay, so the paper version and the Go formative works together to give you feedback. Okay, so now let's go back to the paper. We're going to go on to the second problem. Second problem is a table, and the question is it a function? And the rule is the x value cannot repeat, and it doesn't, so therefore, yes, it is a function. And the reason why is because the x value does not repeat. So then if I look at this list here, letter D is my answer. Okay, so I'm circling that. And before you move on to the next one, what you should do is try on the Go formative and see if that answer is correct. So press yes. Woohoo, got a green light. And the next one, I decided to choose letter D, which is the fourth reason. And we check it, and we got a green light as well. So great. So good job. Okay. I just want to show you, if you press the incorrect answer and you press check, you're going to get a red light. So then you know that you're going to need to correct, and then you can check it again. And then we see that we got the green light. Okay. So Go formative can be very powerful to help you understand and know where you need to ask questions or try to revisit the problem. All right, let's go back to the paper. So the next problem is this a function? Now this is a diagram. Okay, a diagram has two conditions. The x value cannot repeat, and if you notice, the x value cannot repeat, is not repeating. And the second condition is that there needs to be only one arrow from left to right. And the number 4 only has one arrow, but the next two numbers, this one has 3 and this one has 2, so I know it's not a function. And the reason that it's not a function is because it failed that condition of having just one arrow. And if I go through the list, I notice the reason why this is not a function is because there are more than one arrow coming out of the number on the left. So I know it's going to be letter F. And again, you go to your Go formative and you try it. Okay, so the answer is no, and the final answer is that. Then you press check your answer, and we see that we got it right. So what we're going to do now, we're going to stop for a moment. So if you're watching the video, please press stop or pause on your video, try the problems on the back, and once you try it, turn on back the video to see if you got the right answer. Okay, so right now stop the video and just when you finish, restart it in a few seconds. Okay, welcome back. And so you should have tried these problems right here, and let's see your answers. Okay, check if you did it right. So right here I have a table, and I see the x value is repeating, so therefore is not a function. And the reason I know it's not a function is because the x value repeats, so then it would be letter C. The next one, I have a graph, so I'm going to use the vertical line test. I'm going to move from my pencil from left to right. And if I notice, I'm only touching one point at a time, so yes, it is a function. And with graph, we're looking for the vertical line test, and we only touch one point at a time, so it'd be letter A. The next one is a set of order pairs. So basically, you're focusing your attention on the x values and making sure that the x values do not repeat. And according to this, the x value does not repeat, so yes, it is a function, and the justification is because the x value do not repeat. Very good. The next one is this mapping, and remember there has to be two conditions. The x value does not repeat, which it doesn't, and there's only one arrow coming from the left to the right, so then yes, it is a function. So in this one, you need to demonstrate the two reasons why. The first reason is because the x value does not repeat, and the next one is because there's only one arrow coming out from each number on the left. So on the Go Formative, you'll be checking both boxes in order to get the green light. Okay, and that's why the problem says circle the reason, but also had the S in parentheses because it's kind of indicating that you could have one or two reasons that needs to be selected, and that happens on the STAR test where sometimes you have to select multiple choices. Okay, all right, next one, we have a graph. We need to determine whether this is a function, so we're going to do the vertical line test, moving from left to right. We only touch one point at a time, so yes, it is a function, and the reason is because the vertical line test only touches one point at a time. All right, last two problems. Here's a set of order pairs. Here are my x values, and the 4 repeats. So then it's not a function. And the reason why is because the x value is repeating. So it'll be the third multiple choice, okay, or x values repeat. The last one, it is a graph. We do the vertical line test and see what happens right there. If I put the pencil right there, I'm touching here and there, 2 places. So that is a big no-no to be a function. So it's not a function, and the reason is because the vertical line test, the vertical line touches more than one point. So that concludes the lesson for today. Okay, please notice that if you don't have your Go Formative, you definitely need to do everything on paper. If you do have the Go Formative, you need to do it on paper, but also enter your answer on the Go Formative. Okay, the expectation is that you are entering things on the Go Formative and also writing on your paper. All right, I hope this lesson was helpful. If you need to revisit the lesson, you can always play the video again. Thank you very much for your time. Have a wonderful day. Bye-bye.